Good afternoon and welcome everyone. Thanks for joining us for today's DBA Masterclass. My name is Usama Ahmad. I am a data management business development leader in Oracle EMEA. Now, as you already know, the objective of the Oracle DBA Masterclass is to provide informative updates on Oracle database and data management solutions to DBAs as well as data management professionals and architects and also managers. And if you have been following us since the beginning, then you'll probably recall that the first session was held back in September of 2020, which means that this month we had just actually hit the third anniversary. And what, a great way to actually roll into the fourth year than having a session on Oracle Real Application Clusters, which is market leading top class database availability solution that offers superior capabilities for Oracle database scalability and high availability. And in order to talk about it today, we are joined by Anil Nair. He is a product manager of Oracle RAC and ASM, and he is a member of the Oracle Mission Critical Database Development Group. Now, Anil actually joined us last year in June of 2022, and he at that time delivered a session on Oracle RAC fundamentals. And today he's joining us again to talk about Oracle RAC performance internals. We are also joined by Sandeep Dubey. He is an EMEA converged database specialist, and he's also an expert on Oracle RAC. He will be answering your questions on the chat. So if you have any questions along the way, please post them to the Q&A window, and he will take care of answering them. And if we have some time left towards the end, and we have some still outstanding questions, then we might take them live. And in order to stay informed on the upcoming events from DBA Masterclass and the replays as they become available, along with other relevant information, one option that you have, if you are active on LinkedIn, is to subscribe or join the EMEA Oracle DBA's LinkedIn group. So if you join it, then you will see the updates that we are posting on there about upcoming events or past replays. Of course, you can always visit, of course, the homepage of the DBA Masterclass, and you can, of course, find the information also about the latest sessions there. So with that, now I'm going to hand over to Anil to tell us about the Oracle RAC performance internals. Over to you, Anil.
Great. Thank you so much, Osama. Let me start sharing my screen so we can then start. All right. I think pretty much everybody should be able to see my screen now. Excuse my voice, I'm a bit under the weather, but we should be able to cover one of my favorite topics, which is performance. Let's start with what we're going to do today. So today, we're going to cover what the details about the Oracle RAC performance internals. A couple of things I want to mention. First of all, this is, obviously we cover some of the architecture part. The best part that I really like is I'm actually going to cover some live cases that I've seen in the customer field. Obviously taking all the information specific to the customer out, but just to point out what are the wait events, how did I get to the root cause? And the second thing I want to point out is, yes, I'm the person who's here talking to you, the face of the product, but a lot of the work behind this deck and behind what I've learned comes from a team. We call them internally the Oracle RAC performance team. Very, very skilled, individuals who are happy to contribute via me this information. So really would like to appreciate them. And with that, let's jump into it. If you already don't know me, I'm Anil Nair. I'm the product manager for Real Application Clusters, ASM, and pretty much a lot of the things related to high availability and scalability in the Oracle database. I've been around for 25 plus years in the same group, started with the precursor to RAC, which is OPS. Enough about myself. So let's get into some of the topics that we want to discuss, right? I usually leave it here. I'm not going to say something about a future product. I just leave it here. Please take a second to acknowledge it in case I say something about an upcoming feature or something like that. So one of the things that is distinguishes RAC with from the other competing product or competitive products out there is that RAC is able to scale the world's most complex workloads, whether it's being an SAP or a PeopleSoft or any complex workload. We're able to scale it without any changes. So in this example, you would see that even if you have a very, very high workload or high OLTP or very high transactional database, data guard, if the data guard is not able to keep up, because obviously prior to multi-instance redo apply, you would have what we call a single instance redo apply. Now we have multi-instance redo apply. We should be able to scale that up. SAP workload, I already mentioned that. And even the new generation of workloads. What is the new generation of workloads? Is people who have wrote code in, to use, so these are not a little bit different than the typical, what we call as the ERP applications. They are this workloads that use IoT or JSON or any of this new format. And we are happy to say that, I've worked with a lot of them. We're pretty much able to scale more than the 18,000 different kinds of, applications I've seen at our customer sites. The main thing is you don't need to do any change. We keep saying that the application doesn't need to change. Yes, you need to do some configuration changes on the Oracle RAC side, which is we create services and all that, but that's pretty much it. This is very much easier on engineered systems like Exadata. Hope in the future I can come in and talk about Exadata performance features because that is another very interesting topic. And by the way, if you have a wish list of what topics you need to help with or cover, feel free to let me know. Hopefully you've taken my social media tags. Otherwise, you can just put it in the chat and I'll try to make it. What we try to do, and this is something we actually work with a customer who standardized on Oracle RAC, which means pretty much all the deployments are going to be Oracle RAC. Instead of taking one application and then checking on Oracle RAC, we said, all right, let's go with Oracle RAC and let's see. The expectation for us was typically 90% scalability rate. We found that obviously certain applications which actually cannot even scale on a single instance system because of the way the app was written, we did find some of them. And obviously that did not scale on RAC. But you know what? We work with them. There's some application optimization, some schema optimization that help them scale. So that's the idea, and that's the logic that we go with. If you have a test or something, if you have an application that you want to test, and already the better links have been shared by Osama. But if you go to the Oracle, the Live Labs, you would just search for the keyword RAC, and you would see these two come up. I always recommend using the one on the left. As you can see, that's the Oracle RAC HN scalability for applications. You can test it. I've had customers use as simple tests as swing bench to whatever they could get in. Obviously, you can't put a whole huge PeopleSoft or SAP thing there, but you could test it out with whatever you can test and learn from it. What are the things that works? And also, same thing. If you have feedback on some labs that you want to try, please let me know. With that, let's get into what is the Oracle RAC and how does Oracle RAC performance, how is it possible that we are able to do all of these? Well, we didn't do this in 1 year, we've been doing this over multiple versions. We started with things in 9i, like, those who are old enough would remember this thing called Cache Vision, which was introduced in 9i timeframe, and we have built upon those features. These features, if you have compared or if you have experienced with the older release of Oracle RAC, when I say older as in 9i or 10G, you would see that basically with 19C, there is a tremendous difference in performance and availability. In fact, we keep saying that there's a 5x improvement in scalability. So if you're running an application on, say, 11.204, you would see, really like 5x better scalability and about 6x better availability. Now, how does this happen? And again, there's a selection of contributing features. We're going to talk about a lot of them. And obviously, if you have questions on any specific, all of them, do feel free to reach out to me. Okay. So let's understand the basics, okay? So essentially, what Oracle RAC is, you have an instance on, you have a database instance on every node. And you basically the instance is having the same structures which you would see in a single instance, right? You have this buffer cache, the shared pool, in memory, and whatever else, miscellaneous things out there. The performance is because we have this big now total SGA. So think about it. If each SGA is 2 gig, now you have 8 gig. If each SGA on each instance is 64 gig, you have 64 times 4, right? So that is a big change that you're getting a buffer cache by itself. The second thing about this buffer cache is, hey, we are not giving you stale data. So we kind of keep that in sync using what we call as the private network. The private network is what we use as a synchronization mechanism so that all the data, regardless of where you access it from, is consistent. Okay. And I keep talking about this in the new cloud era. Whenever I talk about private network, there's a different connotation of private. So let me make sure everybody understands what private is. I keep saying private because this network, whenever I talk to customer, they say, "Oh, I have a 10 gig." That doesn't give me. Yes, of course, it's an important requirement, but what I'm really looking for is low latency. What that means is just because you have a 10 gig, you shouldn't share it with other things, because if you share it, you are going to impact your latency. The more faster you can send data across, the better performance would be. The second thing is I keep highlighting it, we recommend that private network to be private so that nobody else uses it. And also because we send the cache as it is on there. So you don't want it to be exposed to an external network. So, for security reasons also, you want to make it private. We also provide you mechanisms by which you can depict a certain subset or 2 or 3 interfaces or 4 interfaces for private network. And we protect that in the sense that if one network goes down, we use the other interface and all that. And I've talked about it in the past, so I'm not going to spend much time on it. We also support, although I said let's make it separate, I understand today's world is all about virtualization. So in a hyperconverged infrastructure, you can use it. Yes, we recommend that you make sure that it is as private as we can, because maybe as a DBA you cannot find out, because once it's virtualized, that's the whole essence of virtualization, is you don't really need to know whether it's private, it's physically or at the bare metal level, whether it's a isolated network or not. The idea is, it's virtualized for you, but as long as we make our requirements clear as DBAs and system admins, it's very easy for that to be implemented. And that can be done via, QoS setting at the switch and all that. That is something you got to dependent on the network vendor and how you communicate with the, or what which infrastructure you use. By the way, I think there is a lot of questions, and I'll try to answer some of them in the end. And also my colleague is trying to answer this. The good, really interesting questions, I would try to take them at the end. So basically, we have talked about this in the past. We use TCP for our communication. We have TCP as a communication choice. We use UDP though, even though UDP, we have, we understand it's a stateless protocol. But what we have done is we have built a scalable IPC LW layer on top of UDP on that. So what that means is, IPC is inter-process communication. LW is a lightweight. The lightweight indicates that if you have done any network programming and you want to send and receive messages over a network socket, there are a lot of things that needs to be maintained by the operating system. As many of you know, in Unix, everything is a file. So when you have a socket, the socket is as a file. You have to have certain other networking connotations that needs to be represented as some resource in a file system. What the lightweight layer does is essentially, helps us reduce those number of resources. So this makes it easier to have a lot of processes that are doing cache fusion without adding the overhead of all these extra things that are dependent. So this is something that we do. We also provide on top of UDP, which is typically a stateless protocol, state information, and you also try to take care of flow control and retransmission. Okay. How can I go and talk about anything else? Even this is the only slide on Exadata, but we want to make sure that people realize the difference. We talked about latency. This is very important to know. What is the one thing that really Exadata provides for us as in RAC is RDMA. And I talked about RDMA. DMA is direct memory access and RDMA is remote direct memory access, which means Node 1 can access and read the contents of Node 2's memory bypassing the host CPU. And I've talked about the performance implication. We are like 3 times faster than typical other messaging protocols. This gives us so much better performance because remember, performance is dependent on latency. The faster the latency, the faster the workload goes through. So if you want to know more about it, I have a white paper, apologies, I should call it technical brief that talks about all of these optimizations, and I'm working on the 23C specific aspects, should be there soon. There are some really interesting topics that I'm going to talk about in this context, and I'll highlighted them, but we'll cover them as we get into that. So when you're trying to start performance tuning, the first thing you want to know is that are we using the right network, right? The private network. You can look at the cluster, the network is in generic systems in the AWR report and on Exadata. This is the most important thing. I think I've talked about this in the past, which is basically what is a lost blocks. Now, remember, we are not talking Exadata here. You know, Exadata, you never have lost blocks because the block, send and receive is kind of, done. The onus of making sure the block is sent and received is on the protocol itself. It's not the typical IPC lightweight that we use in generic systems. So as I said, we have built up on top of UDP, our own mechanisms for flow control and resend and retransmission and all that. So what happens is in this case is essentially, if you see in this AWR report something called lost blocks, there are 2 things you should know. That is, one is first of all, lost blocks is not a good thing. B, it's not the number. It's not like 348 or 700 or 600 or 250 is a bad number. It's the rate of increase. It should not keep going up. Once in a while, yes, there may be some lost blocks, even though you try your best. And so let's understand what's a lost block. So what happens is, let's say instance 1 sends a message to instance 2 and says, hey, I want this 10 blocks of Scott.emp table. And instance 2 says, here's the block, go read it, and it sends it. But instance 1, never receives the block. So what happens is instance 2 is still waiting. The LMS is saying, hey, you know what? I sent it to you. Why didn't you take it? And it's still waiting. So what instance 2 does is it tries to send what we call as a side channel message. A side channel message is a small, very small, considering the size of the blocks. Like if you look at an 8K block, and if you say 10 8K blocks is 80K, we try to send a very small message. The idea is if that the remote node acknowledges the message, that means somehow it has not received the earlier blocks, and therefore LMS tries to send it again after increasing the lost block count. Now you would say, all right, that looks like a network problem. Well, 2 things you should know. One is the lost blocks are only reported on the instance 2. So obviously you want to look at instance 2. While you're focusing on network, you should also realize that it's not just network, it's just sometimes CPU. And you'd say, what's network got to do with CPU? Well, the private network and CPU kind of work hand in hand. If you look at how we communicate, regardless of RAC or what, even on your laptop, when you go to say www.oracle.com on your laptop browser, these things happen in the background. Somewhere a packet is sent, which goes to some IPC layer, regardless of RAC or not, there's some communication layer. And then there is some, context switch, because now from user mode, you need to go to privileged mode or sys mode. Then it goes into the driver stack, and then the NIC, and then the wire, and then all that comes back. Now, imagine if during a context switch, the CPU, or there's no CPU, or the CPU is 100% busy. Well, what happens is, we cannot, acknowledge that context switch, and we wait. How long do we wait depends on the system itself. And if you wait for more than a threshold, then obviously LMS will say, oh, I'm going to resend it back to you because, I cannot keep waiting forever. And so my point about all this thing is that when you look at network issues, also look at CPU or lack of CPU, CPU busy. As a whole, note, and I tell you, this note I started writing in 2008 or something, and I keep updating this note, which is basically common costs resulting in blocks lost. So if you look at this note, it talks about a whole laundry list of things that we have learned since, almost, if you take 2010, that's like 15, 13 years now. We keep updating it because we find newer issues, newer ways by which things get messed up. One of the things that, this is not a particularly a RAC issue per se, but one of the things about highly configurable operating systems like Linux is there is so many settings, and there's so many settings for different types of communication. Well, RAC needs a particular types of communication pattern, which is basically we want to send 8K blocks across the nodes very quickly. And so there are some settings, and these are the settings that we recommend. Now, we made it easier for you. You don't have to go through this list and say, oh, did I do 1, 2, 3, 4? What we have done is we have added a lot of those checks into AuraCheck. So if you're using AuraCheck, you should see that these checks are the checks that I mentioned are covered in this. Okay. If you've done this and this is a new deployment and you want to just test your private network performance, there are various tools out there called iPerf, regardless of use iPerf and iPerf 3. This gives you a fair idea of the bandwidth and the latency to send, and receive. This is some of the options you would see. For example, -C is the network IP, and then you would use the block size, and then you would use at the window. And these are the options that I use when I test on my systems and get some baseline performance, so I know my network is ready. Okay. So now we talked about network and we made sure cache fusion, yes, we need fast network. The second thing that we do is we do what we call as optimized placement of block directors. Now, let me be clear there. A block director is not a new concept. We're trying to move away from the block master. We're trying to rename it as, or we have renamed it as block directors. If due to muscle memory, I keep saying block master, I really mean block director and do not mean the block master. So what is this block director, right? If you have attended my sessions in the past, you would realize that as we have different instances and we have a lot of buffers, what needs to happen is every buffer could be, in other instance too. For example, let's say scott.emp row number 1. It could be an instance 1's buffer cache. It could also be an instance 3's buffer cache. So which one is the latest? Which one has the, who is responsible to make sure that when a buffer is requested for that table or for that row, how do you know which is the right one? So there is this concept of a director, kind of like a manager, I would say, who knows about all the people who report into that org. So director would know about a certain subset of some of the blocks. So there is no 1:1 mapping as depicted by the image here. Usually one block director can take care of hundreds of thousands of block states. Okay. In the past, when we started up an instance, we would just distribute this across all the nodes, because obviously we want to spread them out so for availability. What we have done now is we now try to track where is the access patterns from. So if you have a 4-node cluster, we would say that, all right, node 1, we're using sales table accesses more than node 3. So wouldn't it make sense to keep a lot of the directors for those tables and their associated indexes and other things in that same instance? Makes perfect sense. Now we do that. So we do optimize placement. During runtime, let's say your workload has changed. Now, workload is now going to node 3 more, and therefore the access patterns is changed. We do what we call as, DRM, and we move it there. And during planned shutdown or planned outages, like we say, like, okay, you know that something, you got a heads up that, power is going to go off in like next 10 minutes. You have some time. So what you can do is you can shut down the instance. Now, remember, if in the past, when you shut down the instance, we would take the instance down, then everybody would do the reconfiguration, the surviving nodes. What we have done now is, as you can see by the animation, please pay attention to node number 3, that we would actually move some of those directors into the other instances. So this is done prior to shutting it down. The advantage of doing it is the other instances are better equipped to understand the state of all the blocks that are covered by those block directors. Okay, so that's one. The second thing is Yes, Oracle RAC has many additional processes, but LMS is what we call as the workhorse for cache fusion. And LMS manages what we call as the global buffer cache. So if another node wants some from some block, LMS is the process which would make sure and will provide it. LMS has its own retry mechanism, to handle what we call as the shipping failures. We talked about one pattern earlier, but there's a lot of more patterns. It's a bit expensive to retry because remember that it's a queue-based mechanism, which means if you have 100,000 requests and there's only one LMS, we go with one by one. And so if one send does not go through, we have to do this again, which means the rest of the people are waiting. Okay. Now there are some optimizations we have done. We can offload certain work to what we call as LMS CR threads. A CR thread is a consistent read thread, and I explained to it in the next slide. Also remember, LMSs cannot be hung or busy, because if that hangs, we are really done. So we actually have monitoring capabilities for LMS using this LMS heartbeat mechanism. We have what we call as LMS CR threads, which basically is an automation. Customer doesn't have to do anything. If there is a large transaction, in this case, from time T, we have to time 5,000. There is a lot of activity on an account. If a process comes in and says, I want to find out what is the state of the block at T plus 1, and the current state is T plus 5,000, then the LMS has to go and apply undo. And it goes applying undo back from 4,999 to 4,998. And then it reaches the one that we want and it sends it. This is not a very efficient mechanism because LMS is stuck. So what we do internally in Cache Fusion is we'd say, hey, you know what? This is a lot of work. I will spawn a new LMS CR thread and let it work while I continue to work on the other things. So this way we try to reduce the reasons for which LMS have to wait. We also have this new thing called in-memory commit cache. So what happens is in-memory commit cache is if you look at certain workloads, you would see that there is a lot of undo header. You would say, I never did rollback. Why am I getting undo header? Well, what undo header is basically when you're inserting into same table from multiple instances, you would have certain transactions are ahead of others in the sense that when you insert something, you're ahead of other, but you also have this primary key that you need to maintain. So we need to make sure that before we commit, we check in the remote sites whether that is inserting the same record as ours. So we have this mechanism by which we have to read what we call as the transaction table entries, which are typically stored in the undo header of the block. As you can see, via this animation here, it needs to send messages. So what happens is on the LMS, we have to send a message to the foreground, and this is typically 4 messages that we need to send. So this would be in the past what we call as 4 times GCCR block 2-way. Now with this new mechanism that we have this in-memory commit cache where we maintain a small cache so that this can be queried and we can get a batch of transactions to be queried. So it's not like one. So we kind of get up to like 30 transaction IDs. And we get one message. So there's only one message required to be sent. So this instead of this 4 CR block, 4 CR 2-way block, block 2-way weights, we see more what we call as GC transaction table weight. This should be very less because we are not sending 4 messages. Remember, we are optimizing not only the latency, but also the protocol to help improve performance. Sequence contention. Almost every application uses sequence of some sort. If they don't use sequence, it's actually worse, because the thing I've seen is they would have a row in the table, and every time there's an update, they'll say, update that row, make that column +1, and that's the worst thing. Sequences are actually much more optimized for these kind of things. Yes, there are some ways by which sequences can show performance issues, and this is one of the way you see it. If you see this, that knows that it's a sequence issue. This is not a RAC issue in the sense that you have some synchronization mechanism to ensure that you get an ascending order of values. Obviously, we need to make sure there's some lock, and the more you use the lock, the more there's contention. On RAC, we have provided perhaps what we say the only mechanism by which a DBA is to plan or intervene and do this. So we have the scalable sequences where basically, typically sequences are mapped to an instance where you can mention using the scale option and the extend option, whether you want to use the instance ID when generating the sequence. This means that it is much more easier because we get a batch of it, and then the local instance, whenever it's generating the next value of the sequence, doesn't have to go across for that. And this is what the statement is, and I actually am working on some performance numbers to show how much this has improved. I'll share that in a blog post shortly. Okay. Then we get into the part of hang or slow performance. I always say to customers, there is no API to find out if something is hung. There is no is instance hung, or is my kernel hung, or is something, there's no way to find out. Everybody does some heuristics. If a kernel is hung, after some time, things will serve. Obviously, the kernel is hung, the whole system is frozen. You can't even, type anything in. But the moment you figure out, that's when you actually look at whether your keyboard is connected. So you have to do this heuristic mechanism, right? So same thing for the database. You have to figure out whether it's a hung system or it's just very, very slow. And there's a difference. Okay, and that's very important. So cluster-level processes try to figure out if something is hung. The understanding or the underlying assumption is that it doesn't matter why it's hung. As long as you have more than one instance, if we can evict or kill the instance which is bad or hung, we just take it away so that the healthy instances can continue. And that's the idea. So if you look at it, we do a couple of things here. One of the things is we make sure that CSS and CSSD and OCSSD try to make sure that the instance and the host is up. Then we have something called as the agents, which make sure that these processes can continue. Then, as we came into this, we found out that, hey, you know what? It's not just the server or the physical host. The file system needs to be monitored too, because there have been cases where the file system got hung. And so we now start monitoring the file system too, saying, hey, is this UI app blah system up and running? Is it accessible? Is it hung? So this is some things we do to make sure that you have high availability. We also do this on specifically on Exadata because, as you can see, on physical systems, sometimes we can't monitor. So auto monitoring of CRS home is disabled in non-engineered system. We monitor the GI home, especially because if GI home is unstable or hung, the whole thing is going to be hanging. Right. We also try to make sure that we don't suffer from what we call as OOM, out of memory. So we try to pin our memory when we start up. So there's a bunch of things we do to make sure we don't hang. On the CSS side, we also found out that the CSS, as we started, as I said, in 9i timeframe, that's the origins of the CSS. For those of you who don't know, it has become a huge process, which has become a lot of threads. What we found out is we could actually split the functionality into two, because what we did is to split it is we found out that, hey, certain errors or certain actions of CSS, we can recover without actually going through this whole reboot mechanism. We put that into a separate process, and certain things which we know that if a state information or some information is lost, we better reboot the node. We split it into the second one. So that way we made sure that actions or events that cause in the past any issues with the CSS to cause a reboot, we try to reduce it by making it into two processes, a recoverable process and something but we require a reboot. Right. The second thing is we also track this. I don't know if many people have seen this. These curly brackets are very important. You can actually get the state of the object of the whatever object is or resource is being tracked and look and correlated. And I have actually talked about this in my previous sessions. If you go to my SlideShare, you would see a list of things on how, considering that the number of logs we have, how easy it is to track the resource. Like, for example, if you are interested in the database resource or instance resource, you can track the events using this curly bracket that I highlighted, and you can see this information, so it's easier for you to track it. Okay, so this is something that we do to make sure that the system is not hung. Now, let's say the instance-wise it is hung. What that means is the process is not hung, but the instance is not progressing. So I talked about LMS. LMON is probably the second most important process in this context. That if, for example, LMON thinks that the instance is not responding, it will be the one who to evict it. Okay. We talked about lost blocks. Lost blocks is basically LMS saying to the foreground process that, hey, you're not, I'm sending you something you're not acknowledging. It could happen into what we call as a send timeout. This used to be quite common in the past. A send timeout is pretty much like if you're talking on the phone, in a very bad reception area, you're thinking that it's the other side that is not able to listen. The other side is saying, hey, no, I have a full 5 hours on my things. Why? It's your side. So basically, it's each person saying, you're the problem, you're the problem. The problem ending up to a send timeout and eventually crashing. It's a little bit harder and trickier to get to the root cause because each instance says the other guy's a problem. So for example, in this one, it says, hey, IPC send timeout detected. This is the PID. This guy said this is a problem. And the other side said, no, look at it. This is the other side. And what we have done to solve this is we introduced a new process called a local monitor. What that means is the LMHB is basically something that will monitor these processes. Now, what does that mean? Let's understand this. Now, remember, when you're trying to send messages across the network, right? Usually, why does the other process, one of the process, not acknowledge the messages? Because could be network, obviously, yes. Could be CPU. Now, if the local process heartbeat is monitoring this process. So let's say the LMS or the LCK is not heartbeating locally because it has no CPU. Well, the chances of it acknowledging a message that is coming from the remote side is even lower. So we kind of take an action even before the issue occurs. So that's very important concept to understand. So in this case, we have taken care with this heartbeat mechanism, certain types of errors, which now you can see as this 29770, 771. We try to take them out as long as, it's a non-fatal process and all that. Okay. We even evict sick unresponsive nodes because, as I said, if it's not just the LMS or LMON or any other processes that are complaining, we also take care of those which are unable to respond in a timely manner. We have introduced this concept of RAC, reliability, database reliability framework. We talked about this in the past. There's a bunch of changes coming up or improvements coming up to this. And essentially, the thing is same, right? We monitor, we try to optimize resource usage, we dynamically adapt and reduce brownouts. One of the things I keep talking about in this context is DRM, right? If there is very, very busy workload, there is no CPU, things are going crazy, maybe we should delay DRM because even though DRM would have helped with the performance, the fact that we have no other resources is a bad thing. So we kind of stop doing this. So this is one of the things that that benefits from this feature. Okay. Then we get so let's understand some of the basics of wait events. Okay, I explained the architecture. I explained the way to distinguish a hang versus a slowdown. Let's get to the concept of understanding what's a wait event, right? I've talked about this slide in the past. Essentially, cache fusion, what I call is there are typically at a very high level 3 messaging patterns. Two-way block transfer, which is basically send and receive messages across 2 instances. You have a three-way, which is basically your requester is in one node, your director is in another node, and the block itself is on the third node. So you have like three messages. And what we have is the two-way lock grant. Two-way lock grant is, hey, I want this block. And the other node says, dude, I don't know what block you're talking about. I don't have it. Go read from the disk. And that's the third one, right? The good thing to know about this is, even if you have 16 node cluster, you don't actually send to all 16 nodes. You actually, at max, go three-way block transfer. Okay. When you look at a wait event, let's break this down. GCCR block, two-way. Well, let's understand what this pattern stands for. GC is global cache. CR is basically consistent read, or current means the current one. Whether it's a block, that's an actual block that was returned, or whether it was granted, that's something, grant means you have to read from disk. And then we have a performance in, whether it's a two-way, three-way, busy, and all that. What we can infer from these things is, right, a two-way or three-way means we immediately got a response back, which is good. If we get congested, that means LMS was busy. That usually means you have less CPU. So the moment I say congested, I look at OS Watcher kind of information. If it's busy, it means LMS is unable to immediately help you. And why is that? It could be that the requesting block is dirty. What is dirty block means somebody made changes. So we need to flush that changes to disk before we send it. And that's why it is. And that usually means IO. So then I would go into the IO layers to see. Okay. When you see GCCR block, typically we want to make sure that most of the latencies is less than 1 millisecond. On Exadata, obviously, with RDMA, you get less than 100 microseconds. If you see high, then we need to look at interconnect congestion and other things. If you see congested, we should not see this on healthy systems. That just means that there's some problem with LMS scheduling. It could be LMS is not running in real time, or LMS is, there's not enough CPU in the system, or whatever. If you see GCCR GCCR block busy, it's mostly an IO, because somehow the dirty block or something is not able to read or write that changed block or the dirty block to disk. Then that's the problem. GC buffer busy, acquire release. Acquire means someone wants to read a remote block and it has not yet completed. That's because somebody else or a remote block transfer is in process. As in, instance 1 wants it from instance 2, but maybe instance 2 is busy sending it to instance 3. So there's that thing. Release, meaning a block got released because it was requested by another instance. So this is, the acquire is before the thing. And if we get released, that means the block which we wanted from node 2 is already moved away to some other instance. Okay. Don't confuse this with the GC current block. So if there is no GC CR current in before this, they are like a little bit different wait events. Some other patterns is, if you see GCCR current request kind of things, you would typically not see this, the AWR. You would typically see this in ASH report or in hang analyze. It's basically the precursor to the GCCR wait events, like the GCCR block, GCCR. So we start with the request, we end up immediately to a block grant or a CR current block grant. So if you see this, it typically means the system is extremely slow, and this is a very, very small outlier. So that typically is very rare. So that's why we'd say that you generally don't see it in AWR. Okay. If you see GCCR current block directory, this is mostly on Exadata systems. Basically, we're able to do an RDMA read of a remote buffer within less than 10 microseconds. I talked about what RDMA remote read is. GCCR current, multi-block request. This is basically that, if you break it out, a batch of requests was thing. As I said in my example, if you want like a bunch of blocks from the scott.emp table and they're spread across different blocks, and we get bunches, of blocks. It's not just one block that we get. And request is used when all the requests were fulfilled. In the sense, if you had 10 blocks that I requested and I got all the 10 blocks, good. A grant means the cache fusion protocol will say at certain time that, it's much faster for you to read from disk. And this is because today we have storages that do what we call really fast reads. This is not the storage of 20 years ago. Nowadays, you have storage which a lot of cache. So the time to read these things is extremely low. So we are aware of this. We track this, and we sometimes say instead of doing a request, let's do a grant. Okay, and mixed is when we get a mixture of both. Some of the common things I've seen is log file parallel write, which causes our GCCR block busy. As I said, if there's a dirty block, we need to write to disk. If the time to write to disk takes long, then the GCCR issues could. But they are basically a side effect of the log file parallel write. If the block busy, we see that's because we are getting a GC buffer busy acquire, which basically means that we're trying to pin a buffer, which is pinned by some other session. So now we have to wait until that thing is finished. Okay. Now, again, that happens because why is the earlier session waiting? Most of the time, it's because if that session itself is waiting on that dirty block to be written, there's some kind of IO issue that we need to figure out. Whenever customers see GCCR, they assume it's a RAC issue. I keep telling that GCCR buffer busy, block busy could be index issues. As I said, NQTX, row contention. So if you solve the TX contention, you would see immediate benefit on the GCCR block busy. Looking at GCCRs, we need to make sure that if you see a lot of GCCR current block 2 way 3, we need to look at the run queue length at the operating system, the OS watcher, the LMS priority, and also the private network performance. Now you say, okay, this is too complicated. I have so many wait events. It's very impractical for me to go and read each, look at GV views. I have an easier, typical way, and I'll explain to you when somebody says I have a RAC performance issue, how I address it. Okay. Some of the other things continue. Whenever I say congested, immediately in my head it goes LMS, CPU. LMS is not scheduled, lack of CPU. Okay. And then same thing with GC current block busy. The same thing we talk about the flush statistics in terms of whenever we are trying to write to the change block. Finally, the GCCR block lost. I talked about GCCR block lost in detail. We need to figure out, run the ORA check, make sure that these things are, configured correctly. SV contentions, basically sequence issues. I provided a way by which you can find out. If you want to know specifically which sequence, then the P1 that is reported along with the NQ would tell you the object number of the sequence. Index split, we have this thing called as an RGI workload. RGI workload makes it harder to, essentially, it makes it, whenever you have an insert, we need to split the block for the index to accommodate the changes, and that takes time. So that's the time we wait for this index split completion. I talk about it in my slides. So if this is, again, the basics of understanding what it is. Now, at a very high level, obviously, we cannot be logged into every instance we are managing to GV and V views to keep monitoring that. So where should we begin? I usually start at a higher level. When somebody tells me, this is the most common thing, actually. Internally, I try to monitor and respond to an internal, what we call as a distribution list, RAC performance. And I try to look at most of the common things is, hey, I was running fine until I applied a patch or an RU or an upgrade, and I get some performance problems. So usually I look at, I tell them, hey, did you have a AWR report before and after? So if I look at some of the things, this is what I would typically look at. Is a LMS running in real time? Is the number of LMS is good, as in the number of before and after? Look at the load. So if you look at the load, you would see that global cache block received and served. So in this case, roughly about, say, 20,000. I make sure that the before also is 20,000. I also make an idea of what is the interconnect traffic, right? Here it is something like 173 meg. What is it? Another one. Usually I see some pattern has changed, and that's when I try to delve into figuring out what it is. Okay, sorry. Then I get into what I call as certain specific things, right? Global current server. What basically that means is we have an histogram. Histogram shows what are the time it takes to pin versus flush a buffer. In this case, you can see that this is actually a very decent workload. Most of the things are finishing closer to the left-hand side. If you see things more on the right-hand side, that's a bad thing. In this case, you can see the pins, I would say almost everything is finishing in less than 10 milliseconds. This is okay. Flush is, also doing it, but it's the way to tune flushes is to obviously to look at I/O issues to write that block to the dirty block buffer to the disk. Okay. If you see high flushes, you need to look at the other nodes. So if you have a 2-node cluster or 3-node cluster, you need to look at the other nodes to find out why the flushes are taking time. Because remember, this is the server, the server side. It's requesting it from the client side. So the client side, which is this other instance, that's where the statistics would be. This other thing that I noticed in an ADDM, if you know what is an ADDM, is a consolidated AWR report. Especially sometimes I see this kind of things where certain times you would see that the number of congestions are seen, and this congestion is, if you see, it's more towards instance 2. There's a lot of work on instance 2. Now this could be perfectly fine because the customer may be planning to have this. This could also be because instance 2 may have 8 cores and instance 1 and 3 may have 64 cores. And I actually saw this in a live customer case where that instance 2 was having 1/4 the amount of CPUs, but the customer had configured it to run the same workload in a similar fashion, which means the SGA size was high, the number of services on that was high. So what happens is you'll only go as fast as the slowest member. In this case, we found out that was the problem. There was not enough LMSs, so we needed to make sure that that instance is configured correctly. We kind of had to reduce the SGAs so that it could perform in a very consistent and coherent manner. Now that we have reached here, let's see, we can go through some common performance problems. So common performance problems, right? So we talked a bit about what an RGI or a right growing index. Right growing index is basically, as the workload indicates, the way we keep or maintain or manage indexes is anytime you have increasing value and you're putting index on that, over time you would see that the index has a lot of what we call as accessing higher values for that index would take you more block reads that we need to do. And this is reflected in the AWR report with all these various wait events. What has been done to fix this is we have done some implementation. So as I explained in the right growing index concept is that every time the block gets filled up, you need to split the block into 2, and every time, as you can see, the left side of these blocks are kind of emptier and the right side goes bigger and bigger, and it goes takes more accesses to get to that block. So this makes it harder and more overhead on performance to get to use the index. So what have we done? So we have improved a lot in this area since compared to 11G. This is really, as I said, not a RAC issue, but basically this is something that we need to help for our customers. So we've done a couple of things in this. One of the things is we have this commit cache. For Exadata specifically, the commit cache, the undo block RDMA read, the smart fusion block transfer helps RGI-based workload. For the non-Exadata customers, we've optimized, what we call leaf block splits, and I get into that more details shortly. So how do you first identify that? If you break it up, you would see that in the AWR report, we're waiting 22% for global NQ handling. So this is 21% here and then 1% for the latch. So this is what you see, that we are typically 50% of for global buffer contention. So essentially now we are waiting for this, and this is contributing, this split is, this index issue is contributing about 50%. So this is something that we need to fix. If you ever see this in a customer workload, we need to fix this. So what we have done, right? We have done keep branch block at split. What that means is basically in the past, when we're trying to split it, if there are multiple branches, they could be aged out or being pinged out into the other instance. We kind of prevent that now. We said no, let's try to make sure we do it as quickly as possible, and let's not allow it to be pinged out. Scalable sequences already talked. That's something a DB has to do. But the rest of the features are actually something that you can use without any changes. Delayed ping. So when the redo or changes to a block has to be flushed to disk and the redo is pending, we allow the local sessions to make more changes to the block. That makes it easier than every time you try to make a change, redo, send, get it back, make a change, redo. So we kind of try to batch it together. This is called as a delayed ping, and it makes it easier and more performance efficient to help make local changes that can be done without actually sending the block via cache fusion. We also have fast index split, which basically allows the split to be completed in the buffer cache rather than using the global enqueues. So obviously, the idea is that use the mechanisms of the buffer cache to synchronize this rather than asking for a global enqueue, which itself might take time. So there are some ways that buffer cache provides synchronization mechanisms, and this is perfect. So we take the block, we take the synchronization mechanism, split it, get it over quickly, which we call it as a fast index splits. All of this help improve performance. So if you have a baseline, to now we have 50% improvements. So this really gives you some insight into what the new generation of RAC, as we call it in 19C, can do for improving your right growing index contention workload. Let's look at some of the other things. The second part is I've seen when there's a lot of data and they all cannot fit in the buffer cache. So we have the data set size greater than the buffer cache size. Usually this is perfect. If you have a lot of read, this is perfect because now you can actually scale better. Okay. This is good as long as there is enough CPU. Because typically what happens is the bigger the buffer cache, the number of CPUs is higher, the more number of LMS, this is good. But if you see GCCR grant two-way and a lot higher, in this case, we are seeing, although the average wait is in microseconds, the total time wait is in 2000 seconds, right? This is typically indicating that the cache is good, the number of LMS is not able to keep up, which is basically leading to LMS saturation, right? And why is that? That's because we work on a queue-based pattern, right? If you look at the network, we get from the network some information and we send it in the queue. You can see it in the animation here that every time we get it, we go from one to, we go one by one. So that if the LMS is not able to be scheduled, obviously then it affects it. So therefore, you want to make sure that LMS does not get CPU bound. Okay. And you can see this much easier. In fact, what we have done is in this case, we automatically try to run the LMS in what we call as a higher priority, and that helps with performance. We also try to increment the number of LMS based on the automatic detection of number of the CPUs. If the LMS becomes very busy or saturated or CPU bound, you would see congested. We talked about this. Now it should be very clear by now. You can see that the average wait is 121 milliseconds, and that's not a good number. So you should really try to see what is the scheduling issue that's causing to this horrible latencies. I talked about LMS being running in what we call as higher priority. So if you look at a system in 19C, you should see higher priority, right? I just mentioned that if you look at a 12C system, you are running in a higher priority, but you can see that you might be wondering, hey, what happened in 19C? Why did we run back into TS? So well, that's because compared to a previous release, now we are a little bit able to benefit from the multi-core modern CPU systems, right? What that means is we have actually made it such a fine-grained choice that if you look at the LMS, we have a threaded it, and therefore the threads run in what we call as typical normal mode, and the certain threads or the certain processes of those LMS now run in a higher priority. This is kind of like optimizing it to the ultimate best, right? So you would have the process running in typically what we call as regular mode, but the threads of it, we kind of elevating it into running into higher, what we call as higher priority mode. This is not just for LMS. We have done it for other processes. We have done it for LMD. So if you see LDDN, that is a thread, a process that is where the LMD functionality was broken down into two components, and they themselves would be running with a threaded model. Okay, so you can see that LMS itself runs in what we call as higher priority. The threads run in the typical elevated priority, as we call it. The third type of workload we have seen that affects, or third kind of issue we have seen that affects performance in RAC is the slow redo flush. Well, we talked about this enough. Whenever there's a dirty block, we need to write to disk, and if that disk is slow, we have to wait. You would see this typically reflected in the AWR report like this. Well, obviously, then we need to look at how we can make it faster, maybe move the redo to a disk group, which has faster disks that can make sure that the redo can be written faster. We have this thing called service to instance affinity is broken. What that means is essentially if you have 4 nodes and one node suddenly you need to take it down, whether it's plant maintenance or the power went off on that specific instance or node. So what happens is typically the caches are not warm. So we need to warm that cache, and that requires reading from disk. Sometimes it's also a direct effect of the connection storms. So that happens as a connection storm, then basically then we have a problem, right? So then we need to read all the disk. You can see that in this case, there's a DB file sequential read, bunch of waits. Well, nothing we can do about it. But if you see this, that typically may be because the node was started or stopped on at that time, and you want to look at that. So you're not looking at performance during normal times, you're looking at performance during an outlier event, I would say. Okay. And typically after, you wait for some time and you would see that you would see that eventually the system before rebalance and after rebalance, those sequential reads go bottom, and then the typical wait events that you would see comes back again. Long running transaction with concurrent queries. Well, this has been this big thing of single instance also. Anytime you have to do a block clean out, that takes a long time. And if by chance, when you do a block clean out, you kill the session, that requires a lot more undo to be done. So long running transactions with concurrent queries are reflected a little bit differently in the AWR report. You would see typically a lot of undo header, in the wait events. What you need to do is try to prevent, those sessions to be killed or something. If you have to kill it, then obviously this is a side effect of what you see. Prevent them from happening. If there is a lot of metadata transaction that we fetch from remote instances, a lot of the in-memory commit cache feature should help with those kind of performance issues. And again, let us know if you have some specific case that we can help out, because typically that at a very high level, I can't give you one underscore parameter or one parameter that will help you, but this is typically a side effect of what's happening, that the block cleanout has to occur by reading the undo block headers. Okay. PDB sizing issues. There is this whole note, again, that's a note I wrote. Essentially, what happens is when you have a PDB, so you have, say, 10 PDBs on a CDB, or 30 PDBs in a CDB, or maybe one. We don't know how much you're going to have. So what happens is in the cache fusion layer, we say, hey, let's try to use the cache fusion into smaller chunks for each PDB. So we kind of come up with a heuristic mechanism. Now you might say, hey, I'm going to have 1,000 PDBs. Good for you. Or some other customer would say, I need 10. How do we know? So we kind of came with a default idea, and we found out that that default is not good enough. So this is why you need to set your intended number of PDBs in the init.ora. What that gives you is a hint. So for example, let's say you're going to have 30 PDBs. Even if you set that parameter closer to 25, it's fine. We will plan for that. We want to make sure that it doesn't require to be exact number, but it has to be as close to the exact as possible. Because remember, our variation is 1 to 5,000. So if you give us a hint 25 and you have 45 PDBs, that should be very, very close by, rather than us guessing it to be 1,000. Okay. And if you don't do this, you see this GES resource hash list kind of wait events. This is something that you should look at. And make sure that you set up the PDB, or let us know what is the max PDBs you're going to have on that system. Now we want to get into a live debugging. I know we are like a little bit less time, but I want to get this live debugging. Again, there's a customer case. Customer complained to me that my application is suffering from severe latch contention and row cache NQ after application upgrade. And obviously, everybody for some reason always suspects it's a RAC bug. I looked at it and said, okay, luckily we were able to reproduce some of this internally, thanks to our friends in the Oracle Real World Performance, right? So 2 things we want to highlight here. So this is a typical workload. You can see that everything is flat. Flat is good. Response time is flat, transactions is flat, active sessions are flat, CPU usage is flat, everybody's flat. Now let's highlight some of the things, right? This is the connection pooling setting. At these, so basically we have the pool size, the max size, and the number of threads, the think time. Pay attention to this number, and also pay attention to the number of database sessions. You see that even though you have 144 pools, we have about 210 sessions in the database, out of which 7 is active. Okay, so what we're going to do is now we're going to throttle it. Throttle it means we're going to reduce the think time. When we reduce the think time from 10,000 to 5,000, as you can see here, okay, you can see that the number of sessions increased. So you can see that the number of sessions active increased from 7 to 10. There's a slight increase, but things are good. We keep increasing it. We keep throttling it, as in we keep reducing the think time. Now you're 2,500. Now you can see whatever was flat is slightly getting curvy. There's some storm in the ocean that you can see the waves starting to rise, right? And then we keep continuing to do it, from 2,500, and you can see now we have 11 active sessions. We keep doing it until we get into the point where we are getting from halving it. So we started from 10,000, we now at 1,200. Now we see the numbers are going crazy out of whack. We have 546 database sessions, and we keep continuing this trend, and we make it like even lower. Let's say we make it 600. Now, when we make it 600, now you see, really that is getting bad. You can see the transactions per second is going crazy. Response time is going higher. CPU is going high. Eventually, you see that you get to a point where now you are really getting the side effects of these things being shown. Finally, if you even reduce it to more, you keep getting the number of database sessions increase. Remember, we were at 7 and we had 79. Now we have 79 active database sessions. Finally, when you make it 400, now the response times take a tumble. It was really less than 1, and now we are going to 10. And everything, the CPU is going crazy, and everything is going crazy. The active sessions increased to 1627. Okay, this is after we made the think time very low. So what is the point of all that? The point of all this is that yes, what the customer did is they they upgraded their application. In their application, they had connection pool settings. The connection pool setting was so badly misconfigured that a direct increase in workload on the connection pool level multiplied the workload on the database like 2 times. And to give you an example, typically, so what is a connection pool? If you need, say, 100 database sessions, there is a thing called as a connection pool that you set up where basically you can map it, right? And again, every application is different. I'm happy to work with you if you need specifics. But essentially what that means is every application talks to the connection pool, takes a connection, does it work, leaves it back, comes back, and gives it back to the application pool, the connection pool, and goes back to the application. So you have some mapping. You would say, like, okay, 10 database sessions for 1,000 connections, 100 connections. If this mapping is crazy, every time you have a database application coming to the connection pool, doing some work, it requires a database connection to be spawned and does some more work. It's going to affect in these kind of performance issues. This has nothing to do with RAC. The point being that what you need to do is you need to make sure that these things are configured correctly. If you don't, you'll end up into these cases where now you have 1,292 active sessions. And now, the thing which was working very fine with 7, where you had exactly a flat line with, response time being good, now is reflected in these kind of performance issues. And unfortunately for the DBA, they see this, application guys come and say, hey, NQ latch contention, row catch issues. It's really not a database specific issue. It's a what we call as a configuration issue. It's a sizing issue. So this is something really, really good that we figured out. Unfortunately, I can't share with you the AWR reports of the customer, even though I had cleansed it, but I thought this is a better way to visually show these are the configuration issues that you would see. Okay. So having said that, what we can learn from it is that once we make those think time go better, reduce it, we can get these things back to normal. Okay. So once we made that, from those numbers, we keep increasing it. It came back to normal. The number of sessions have reduced, and you can see that this really helps. So lessons learned: the connection pools need to be carefully considered. The sizing, the min-max size, incorrect sizing can affect it and affect performance issues and even lead to hangs. Number 2, my instance crashed and there are no errors reported in the operating system. So obviously it's a RAC issue, I guess, right? Meaning it's a bug, right? Well, if you look at it, there's this new tool which Sandesh's team has created, which is called AHF Fleet Insights. I have hidden the SR number and all that, but basically in this case, we found out that there is some RMS process crashed with whatever and all that. So if you look at this, you'd see that typically the question and answer session of the customer is kind of hinting towards a crash. But if you get into the details of it, you see that we figured out that this is due to some configuration issue. How did we get to that configuration issue? So let's understand. So when we look at the, AHF Insights provides you with a problem timeline. So if you look at the insights, we get into a problem timeline. You look at the specific resource at that time that was causing the problem, and we get into exactly what caused that problem. And it's so simple. You can do it at your own site. You don't even have to call Oracle support for that. How does this work? Okay. So if you look at a graph like this, this is basically the time the DB down was reported. And as you can see, the DB down is reported somewhere here. The associated statistics which are showing an anomaly at that time is IP reassembly failures. Yes, there were some here too, but that was not crucial or bad enough that caused the problem. But here we kind of tripped over. Okay, so you can see that this being so close to this area is a problem. And so you can correlate these 2 different statistics from different collected metrics that we can correlate and find out that, something to do with IP reassemble failures. And now we can see that the IP reassembly failures are increasing over this time period. Not only that it's increasing, it's also like 25% more if you look at the specifics of it. And the reason we get this is not because it's a physical network problem. This is because somebody forgot to run OraCheck or run this insights, which would have told them that there is a problem. with your setting. The required setting of the IP frag low threshold and high threshold is not set to what is RAC recommended values. You can also see that they don't use jumbo frames. I remember in 2008 timeframe, we used to recommend jumbo frames highly, and people, I thought over the time would have adopted it, but looks like even now we have customers who don't use jumbo frames. If they had run this report, either OraCheck or AHF, we would have actually told them this even before they ran into this problem, right? So this is something that I would say, use it in your system. You would be really surprised at what all things it collects and how it allows you to correlate things from the operating system and from the database side and help you figure out what is the root cause. So this is something you can even do without coming to support. So I would, highly recommend all of you experts out there to download this, play with it, and let us know what are the new things you figured out using this tool. Okay. To end it up, I would just like to say that 19C is a big change from the previous releases. So if you have ever played with previous releases, 19C, as a customer said, this is actually a customer code, which basically says that if you're not looked into the new generation Oracle RAC yet, you have not experienced what we can do for you. A lot of presentations, a lot of technical briefs out there on this. Let me know if you're interested. I can talk to you about it. I want to leave you with a bit of a teaser here. We'd already, Osama said that 23C is released, and you might be very keen on playing with, hey, what's new in 23C RAC? Well, if you are, well, I can tell you there is something interesting, cool things coming up. Good thing is you don't have to wait. If you don't wait, or if you don't want to wait, reach out to me. We can work with you to provide you a beta and make sure that you can test this, give us feedback to improve it, run your workloads on it and say that, no, it didn't help or it helped or whatever is the feedback. I'll be happy to work with you. So if you're interested in 23C beta for RAC specifically, reach out to me. This is the only way you can actually get, RAC 23C on your on-premise system and play with it and give me feedback. So with that, I'm going to take a pause here. I think I've given you a lot of information. I hope there are a lot of questions. I see a lot of them have been answered. And again, as I said, those are the ways you can reach me on social media. If you have questions or if you have any feedback or suggestions on what topics I need to cover, I will be happy to do this in a future session. And I'm just going to take a break, pause now and see if I can answer or pick up any question that I really like and maybe, talk about it. Anything special that anybody, sorry, any good questions that that needs a call out, maybe?
Yeah, so I guess we can see if Sandeep would recommend to answer some of these questions first. So there are a lot of questions that got answered, and there are still a lot that are waiting to be answered. So I guess a lot of questions today. So right, I don't know, Sandeep.
Yeah.
Is there any that you'd like us to take first?
There is a specific question asked for Temenos core banking product for Exadata. Exadata, right. Is there any document?
This is a good question in the sense that as Osama said, I just came from Cloud World, and that's probably why I'm a bit under the weather, because I met with a lot of customers, very busy, no sleep, basically that. But the good thing is I met a lot of finance business folks in there, and a lot of them are using RAC. I've had various other applications that are in that area. I have not specifically heard about Temenos, but I don't see how different or how it could be from the other banking applications. I can find out. So if you really want, I can get a reference customer on that. But even reach out to me. I keep saying anil.nair@oracle.com. I'll try to help you as much as I can to get a reference on this. But it should not be any different. I already had a video on how PayPal, which is in a similar financial banking industry, utilizes RAC to make sure that you can send your payments to each other within, what is that, so fast as seconds. So basically, there has been a precedence of other applications and other vendors in this area which has used RAC and been successful. So I would say that should be my answer to about that. I also saw this interesting question which is about SCSI 3 PR flag should be set on volumes.
Yeah.
No, we don't require that, and that is one of the best things about Oracle RAC is we don't have a requirement on certain storage types to be used. We manage our own storage. As long as the storage can be concurrently accessed from the instances, we are fine. And how do you ensure that? Well, run clue verify and we'll tell you. Okay. Knut asks about, I read about Recovery Buddy. Can this be explained a bit? Knut, I have actually spent a lot of time in the 2021 or 22, and it should be there in the slide share. I explain a lot about it in detail, but here all I can say is that essentially a recovery buddy helps by keeping change of all the transactions made on a node, but the recovery buddy is on in some other instance. So take an example of 2-node cluster. Recovery buddy for instance 1 would be running on instance 2. So when instance 1 crashes, the recovery buddy does not need to go and read from the redo all the committed transactions and the and all those things. So we kind of speed up reconfiguration time. We don't even have to wait for a voting mechanism to find out who the new leader is in this case. So there's a lot more details that I have covered. I think I've actually written a blog about this too. I'm pretty sure I've written it. And if you don't find it, you know how to reach me, so I can tell you about it. Are scalable sequences available in 19C? Well, it is available in 19C. In 23C, we even have an amazing feature, which you don't even need to do anything for ordered sequence performance. Unfortunately, I cannot talk much about it, but if you really want to play with the beta, reach out to me. Just one more way by which you can play with this. But to answer your question, scalable sequences is available on 19C. Let's see. Could you upload the presentation, the OCW RAC session? They're not post. Okay. I thought I did it. I'm pretty sure I did it. I'm not sure if you can, if you don't find it in some time, I already provided my email ID, reach out to me. We should be able to provide that for you. May I have a link about the Exadata-specific optimizations? Well, www.oracle.com/go-to-RAC, GOTO/RAC. That has all the papers. If you don't find it, please ping me, I can help you. In a 2-node RAC, each having 32 nodes, 16 cores, would it be good practice to achieve instance caging by limiting CPU count? I don't recommend these kind of things because they are very, specific to the environment. Why would you want CPU count? It's like saying, hey, I got a 256 horsepower car, but let me only use 12 horsepower of it. You got a 256 horsepower car. Why don't you use it? And if you may have a good case on why you don't want to use it. So let's understand the specifics, but I wouldn't recommend without any approach on that. With the new sequence utility, generate unique sequences number without any gaps. Well, as I said, if the workload runs concurrently on all the nodes, you should be without gaps. But the same issues occur, right? If an instance crashes, there is some that is allocated to that instance. So if you suddenly see the transactions on other nodes, then it won't be in a sequence meaning there'll be gaps. Okay. I wouldn't be recommending creating an application or designing an application without gaps. It's always not a very scalable mechanism in place. Okay. Could the LMS be responsible for a log file sync event? Well, responsible is a very overused term. What I mean by that is, if a LMS wants to send a block to a remote side and the block is dirty, it's not the LMS that made it dirty. Somebody made change to the block. A foreground on the local instance has to be returned to disk. So yes, in a way, LMS can be responsible, but it's not the person doing it. It's the person who's trying to make sure that it's written to disk before it's sent to the other instance. Any recommendation papers or books on RAC internals? I'm very bad at writing things down. I can talk all day about RAC, but I'm very bad on writing it down. There is a RAC internals I saw somewhere. I can recommend to you. I can't get my memory on that right now, but email me and I'll try to find out. What is the best approach to deal with advanced queue tables? I don't think there's any problem. If you have a specific problem, let me know and we can help you on that. In a two-node case instance, select count star from schema table partition 150, exact same SQL, and result 0. That is a very interesting case. I would be very keen to know what happened. I really do. I tell you, Andreas, and I'll call out just to give you credit on that. The last I saw that kind of thing was, I think, in OPS days. But if you see this and it's a reproducible test case, I'm very interested. I have a situation with a lot of index block split. Can I alter sequence to be scalable? If the index block split is due to a sequence, yes, it helps. We need to know some more details, Jess. If we can find out if the index splits is because of, say, small block size. I actually worked with a customer who had a database with a block size of, I forget, 2K or 4K. Recreating the database with 8K took all of that issues out. Yes, it's not ideal. You don't want to recreate your database, but that's one of the things I've seen. So if you see a lot of index block splits, maybe we need to look at what is that index generated from. If it is sequences, then yes, sequence. We can help reduce those things in a way. Yes. What is the recommended method for managing storage in RAC? ASMlib, AFD, or RAC? Well, this is a big topic. Actually, I wrote a blog about it recently. You actually don't need anything. You can just use ASM. The problem with device persistency on Linux, that is the problem. What I mean by that is, in Linux, when you have a device /dev SDC, you reboot it 100 times, it could come up as /dev SDC. It is possible, though, once in a while, if you attach a USB or something else, it comes up SDF or SDQ. How do you take care of this? How do you know that SDC is now come up as something else? Well, the mechanisms that ASMlib or AFD allow you to get device persistency. This has nothing to do with ASM or RAC. You could do this using UDEV, rules. And there's a whole documentation chapter on how to do this. You don't need either of those. You don't need ASMlib. You don't need AFD. And you're happy. I'm happy if you want to use AFD, but I'm just telling you this. So that's just a device persistency issue. It's inherent to Linux. It's not just for the storage, it's also for the network. Networks are considered a little bit more because nobody goes and adds a network card in the middle of a server. Typically, devices or storages get added as the system gets busier and busier. So I hope that answers that question. How do we estimate the CPU required if it is CPU bound? Well, that's a good question, because if you look at certain times that you have 16 cores and they're 70% busy, is it considered CPU bound? Well, I always say, if that 70% CPU usage is affecting your business and slowing down your transactions, that you're causing you to lose, say, millions of dollars of revenue, then obviously it makes sense to, increase the CPU. So that is considered CPU bound. But if that same thing happens 1 second in a 24-hour period, and that doesn't impact you, but you see that sometimes in a wait event, it's a business decision. It's a choice you make to say, you know what, that's fine. That's only I can give it a high level, sorry. In 1916, Thomas says, you provided a fix for bug where it's about the parameter target PDBs. It's recommended you follow the thing and configure the parameter. How will the patch affect us? That the parameters in the underlying algorithm change. Could you lose the word in which the algorithm has changed? Well, as I said, the problem is the algorithm that we use to gauge the number of PDBs that you have created at that time is something that we thought was good at the start. We thought most people would have thousands of PDBs. Well, most customers went with 3 PDBs or 2 PDBs. So our algorithm of guessing what it was really wrong. If you really need the 100%, what do you say, fix, Thomas, set the parameter, I forget, I keep mixing it up, whether it's max PDBs or PDB max or whatever, to the number closer to the actual number of PDBs you plan to have in the system. It doesn't need to be exact. Okay. So that other bug that you talked about, we're still trying to improve the mechanism. We don't have this problem, by the way, in autonomous or Exadata, because we actually have a mechanism in place to detect this. The problem is always with generic systems, because you could have a system that is with 4 cores, and tomorrow you might add 200 cores to the system and suddenly add more PDBs. We just can't gauge this. Also, these are corner cases. But the problem with corner cases is we have to take the lowest, common denominator, and we end up doing the wrong decision. Hope that answers your question, Thomas. If not, as I said, let me know. What is the scenario? Are we going to use hash partition? I really don't understand the question. Sorry, Basant, I really need to know a bit more. Where can we get access to AHF Fleet Insights? Good. If you go to the Oracle website, oracle.com, or Google search AHF Insights, you should find it. If you don't, let me know. It's downloadable through support.oracle.com. I don't know the exact MOS node, but I can send it to you if you don't find it.
I already shared the note, Anil.
Perfect. I'm sorry if I missed it. What tool did you use to check the impact if you change the configuration for ping file? That's a good question. That's an internal tool. But the point is, you can use any tool to simulate work that increases the number of database sessions. I can find out whether we can externalize it. I doubt it. That's because it's a very internal tool, but I can find out. But by the way, Swing Bench is similar. You can use the same thing. Shipra asked, it might be out of agenda, but do you have any sessions related to mirroring in RAC and about RAC 1 node? Shipra, I think mirroring is more of a storage concept. I have presented about ASM in the past. If you have a specific question, I can answer you, or if that is your way to request a session on ASM, point noted. We'll try to do something about ASM also, soon. I've been looking at alert and scan listener logs, but I don't see any error message. Emmanuel, I really don't know what are you looking for. Typically, you don't have error messages in the alert and scan logs if there is no problem. But I guess you have some connection problems, or SQL, LSNR, services, or some kind of mechanism by which you have unable to connect. If that's the case, there's a whole, step-by-step approach on how to tune or fix it. You start with looking at the local TNS names, doing a TNS ping, and going step by step. Most of the time I see that the port is blocked, especially in this new cloud world, world that we live in now. So check that. That's all I can say. Red Hat. Oh, Nancy asked, when will Red Hat 9 be certified? It is going on. And although people think it's just a very simple thing, there is a lot of work involved in the back end. It is still going on. I would say very soon. We are almost there. I can't give you any specific date. Sorry about that. Our network architects have said that they won't enable jumbo frames. Well, as Venu, I keep saying, the difference between a jumbo frame and a regular frame is that if you have jumbo frames, you are able to pass 8192 bytes at the same shot. So it's kind of like saying I have 8192 bytes, I'm throwing it to the other node at the same time. If you have to do the same thing without jumbo frames, you need to send 4 packets. And that's a bad thing, because you have typical, without the jumbo frames, we send 1500 MTU. 1500, if you have to send 8K, 15 4s are 9000. So basically you have to send 4 of them. That kind of slows you down. So your latency would be affected. How much you have to test with your application. I would really also question in 2023, why can't a system admin or network admin set up jumbo frames for the private network? Sounds very, older technology. I would say 2000s technology, I would say. Dheeraj, please take a session on how to interpret AWR report. Sure, Dheeraj, I can try. We can always try to schedule something on that. I've done that. Fernando provided a email. I'm not so sure why, Fernando, but you know how to reach me. We met last week anyway. Carla says, miss any mention of performance in extended rack? Oh, okay. That is a good question. Extended rack is basically rack nodes which are separated over some distance. When you separate over distance, if you remember the famous Einstein, right? Everything is affected by the speed of light. You can only go to a maximum speed. So when you spread up to different spread the rack across distance, latency gets affected. There are a lot of customers who have done this many ways. I know of one customer who does 4-node rack in one site and 4-node rack in another site. They have all their applications running on one site, the other set of applications running on other site, so that they're actually not sending across the extended network, rack private network. This is perfect. Most of what I said applies to extended rack also, except in this case, when you have high latency, the latency is caused because you're separating it out. So that's pretty much all I can say. But I'll be very interested to know, if you want to share your AWR report, of course, confidentially, I'd be interested to take a look and see how I can, recommend anything. Are there any recommended analyzers? Well, AHF is one, Aura Check is one. They kind of make sure your system is good. I'm sorry, I know we are 15 minutes over, but if I want me to answer all of these, I really need to go through them. Osama, I don't know what the pattern is. I don't want to extend this more than to 15 more minutes, but I think there are about 10 more questions.
Yeah, maybe we can give it 5 more minutes. Maybe we'll cover the remaining questions meanwhile, and then we can close. Yeah.
Perfect. All right. Question. So let me try to answer it as fast as I can. LMS process priority can be changed. You don't need to do it. We automatically do it. So don't do anything to change it. We'll automatically help with that. What is the best approach we change to advanced queue? I thought I talked about this. As I said, there should be not much changes. If you have a specific issue, email me, we'll figure out. During a performance test, we had a hang for 3 minutes. AWR shows flashback, log file sync for 44 milliseconds. Wow, that is a bad thing. Log file sync was okay. So flashback log sync, or doesn't matter what it is. The RDBMS is only trying to do what you have configured it for. If it is taking time to write to that, you need to figure out the underlying issue, regardless of redo writes or whether it's a flashback log write. They all have to finish in time. This is like saying, hey, I'm running my data guard in high availability mode, which means until I write it to the remote site, you're not allowed to acknowledge the transaction. Then obviously this is a configuration that you chose. How do you debug this? We need to figure out why did it take 44 milliseconds. So 44, by the way, is a very high number. Vaishak asks, any workarounds to minimize latch-free events? So latch-free depends on the latch. We have ways by which you can improve certain things like the GC specific latches that we talked about. I cannot respond at a very high level like that. It depends on the specific latches. So next one, sometimes Aura agent consumes significant amount of CPU. The only way to resolve is terminating the Aura. Will it be resolved? I would really need to look at the details. Agent is basically trying to monitor the resource. If it's taking CPU, it just means that it's not the problem, it's something else associated with it. Again, we need to look at it. Feel free to, as I said, I've provided ways to reach out to me. I can always figure out what's going on. Basant, in a 6-node rack, how are we going to decide which are heavily loaded and what's the load average? ADDM. I explained in one of the slides, how do you look at various nodes and which node is more busier than the other? Fabrizio, Anil, I need to keep in touch with you. Yes, I already provided all the ways you can reach out to me. Emmanuel, extended rack configuration, pretty much same as I already said. Is there a way to, let's not cover actually this wait only mentioned as to not confuse this with another wait event. I really need to get specifics of it. People do get hung over a specific wait event. Remember, wait events are just a way to point you out to a performance issue. What you are focusing on may not be the root cause. As I said, you might be waiting on a GC CR request event, but it could be that it's waiting on a block split because of an index issue. We really need to understand, as I said, this is a little bit, you need to get some experience dealing with this. If you want help, we can always work with SR way and let me know the SR number. I'll take a look at the SR and the AWR and help you out. I think that's pretty much it. This is a lot of questions. I would like to answer it and apologize, but we are like 17 minutes over the hour. So I think we should stop it now.
Yeah,
Osama.
I think we can't go any longer. I agree with you. What's your preferred way of being contacted? I know that you put the contact information earlier. Do you want to put them again, just to confirm?
Yes, I will
those
show
who
that.
missed it the first time, in case anyone has any other questions and they'd like to contact you directly,
Right.
Yeah, then they can, I guess, reach you on Twitter or LinkedIn.
Right.
Okay.
That's my best way. And as I said, thank you again so much. I'd like to take a second to acknowledge the bigger team between, helping you get all these seminars and webinars to help improve the knowledge. Let us know by feedback or by amplifying our message on social media. If you have good questions, if you have good topics that you want in the future, feel free to reach out to us. Thank you all. Recommended way to reach us is, one of those things, Twitter, LinkedIn, or the slide share. For those of you who are asking about specifics, best way, open an SR, email me or send me via one of the social media thing. I will make every attempt to look at it. Remember, that's not my only job. So if 200 of you do that at the same time, I'll be CPU bound like how LMS would be. But on that funny note, I would like to, take a moment to thank you all again. And until next time.
Yeah, and thanks, Anil, for your time today and for offering yourself to actually even help answering all the questions even after the event. Of course, Oracle RAC is such a powerful solution, and I understand that there are a lot of curious questions around it. So again, thanks a lot. It was an excellent, actually, session, and I'd like to thank everyone for attending and staying for this long. And have a good day, everybody. Bye.